Hello, everybody. This is Dean McRoy, and Mac is here to work with you on fractions and decimals. Just as a reminder, if you could like and subscribe to this video, it really help me out. And if you go to maxtutorials.com, you will find many, many more things that will help you out. Now, the reason why I made this section, there's really nothing new here that I'm going to show you regarding how to solve problems. But one thing that frustrates me about textbooks is, let's say you're working on maybe a two-step equation and you're trying to figure out, well, when do I add, subtract, when do I divide by the letter, and you're trying to move the furniture one side to the other, and you're starting to get it, but then after like 3 or 4 problems, they'll give you a decimal or a fraction. And even though you know how to deal with decimals and fractions, you've been doing it since elementary school, it now is putting something for you to focus on other than that, which is great. You do need to know how to advance that stuff, but not yet. Learn the concept, then let's make it harder. But I got some tips to make some things easier. I just want you to remind you of a couple things with the decimals. When you have a decimal, say, look at this one right here. That's moving a tenth. Okay, so you can move a decimal one spot on these. If we had another one, that would be 100th. Okay, so that's how we call the decimal things. All right, we'll get to that in just a minute. But now I'm looking at number one, and I'm looking at that 4 and that 2, and they just bug me. Now, there's a way to solve these with proportions and all that, and if you know all this, you're getting a little bit ahead of me. But what I want to do is just show you another way to do this. If you multiply everything by the same number, or if you divide everything by the same number, you're allowed to do that, but it's got to be the entire equation. So the first thing you do when you see a fraction is you look at the denominator. So like on number one, I see a 4 on the bottom, and I see 4 will go in the 4, and I look at the other fraction, the 2 will go into a 4. So what I'm going to do is I'm going to multiply, I'm just going to cross out the problem number. That's a multiplication sign. I'm going to multiply each side by 4. And when I do that, remember, that's like 4 over 1, right? And so what's going to happen on the left is the 4s are going to cancel out, and I'm going to be left with an x. But right here, watch what happens, okay? The 2, if we cross cancel stuff, I'm going to end up with x equals 10, and I'm just done. I'm just done with the problem. I'm going to look at number 3. I want to multiply everything. And when I say everything, I mean everything, every term. Now remember, you have 3 terms here. You have a term there, you have a term there, you have a term there. You have to multiply all 3 of those. You're going to pick a number that all the denominators will go into. Well, I know here that if I multiply everything by a 4, I'm going to get rid of these denominators. What's 4 times 4x? So what's 4 times x? 4x. All right, let me kind of make this a little bit bigger here. Now, I'm going to go 4 times 11 over 4. These 4s will cancel out, and I'm just left with a plus 11. These 4s will cancel out, and I'm just left with the 29. Okay, now you just have a normal two-step problem, which we've already been working on how to solve. So your step, if you get a fraction, step number 1 is you're going to minus 11. Did I do anything wrong? No, I'm going to get an 18, and I'm going to get a fractional answer, but that's okay. That's going to turn out to be a 9 over 2. Now, multiply by whatever the denominator is. Or if I take a look at 5, I have to find myself a number. We would call it the least common multiple, a number that they will both go into. So now you always look at, I have 2 different numbers, a 3 and a 2. Will 2 go in the 3? No, it won't. So you got to start at the biggest number, 3. 2 won't go in the 3. Then go up the next factor, 6. Will 2 go in the 6? Yeah, it will. So what I'm going to do is I'm going to multiply this entire problem by 6. Okay? Now watch what happens. I'm going to deal with the very first fraction. 1, 2, and that becomes a 2x. All right, now, let me erase that part. Let me deal with now the second fraction. I got a plus. 2 goes in once. 2 goes in here 3 times. 3 times 5 is 15. Now I'm going to deal with this last one. 2 goes in here once. 2 goes in here 3 times. 3 times 13 is going to be 39. Now, do you feel more comfortable doing this problem? You probably do. Now I'm going to subtract 15 to both sides. Boom. 2x equals 24. So obviously you can just do the fraction part, okay? And you can find common denominators and you can do all that stuff, and that's great. But if you multiply by that least common multiple, and we'll do more of these so you feel more comfortable, then all of a sudden you just transform the entire problem into something that you feel better about. Let's do a decimal. I notice that every single one of these is one place after the decimal. Would I be allowed to just do this? Is that okay? The answer is yeah, it is okay. Because what I did is I moved them all over the same space. What did I really do? I multiplied them all by 10. So what I really did is I just times everything by 10. But if you move the decimal places of every single term the same amount, you're allowed to do that. That's what the times by 10 means. Can you move them twice? Well, if you move all of them twice, sure you can. That would be timesing by 100. So now on this one, I'm going to subtract 24 from both sides. Boom, boom, die. 15x equals, that becomes a 60, and you should know what that is. 60 divided by 15. How many 15 minutes in an hour? There's 4 of them. Done. So now I look at this one. Now watch. Here's where it gets a little tricky. I can make him say 25 by moving the decimal over once. Okay, that'll make him move over once. That's great. But I need to move that one over twice. Okay. Am I allowed to move the decimal over twice? The answer is yeah, but you got to move this one over twice also. So this is actually going to become 250x. You got to add a 0. 2.5, I move them over once. You add a 0, move them over twice. And that's going to equal 1125. Okay. Now you're just going to divide each side by 250. Boom. X equals, well, now this one's going to be, again, a bit of a fractional answer because I know 250 goes to 1,000 4 times, but it's not going to go, any more over. So as I take a look at these, well, what do we want to do these by? Let's go ahead and multiply them by, let's go 5, okay? So now here's what I'm going to do. How many times will 5 go into 11? 5 will go into 11 twice with 1 left over. How many times will 5 go into 12? Twice with 2 left over. How many times will 5 go into 25? 5 times. How many times will 5 go into 25? 5 with 0 left over. I was just trying to find a number that everybody could feel comfortable with. Okay, 25 would have been a good number too. But let's go ahead and go 5 again. Okay, how many times will 5 go into 22? 4 times with 2 left over. How many times will 5 go into 25? 5 times. How many times will 5 go into 50? 10 times. Let's do another 5. How many times will 5 go into 45? 9. 10 twice. Boom. I had to reduce a fraction. Now, when you do it this way, you are going to get big, nasty numbers, but the decimal's gone, which is usually what people like. Well, I can just use a calculator. Well, sure, you can if you're allowed to. Then that's fine. Don't even worry about it. Now, I look at this one. I have to move him twice to get 75x. Minus, I got to move him twice to get 125, equals, I got to move him twice. Well, there's 1. I got to add a 0 to move him again. I'm going to get 550. Now I'm going to add 125 to both sides. So now I'm going to drop down my 75x, and that's going to equal 675. Now I divide each side by 75, and yeah, that's pretty ugly to deal with. But here's what I like. I like that I know that 5 will go into both. I know that 25 will go into both also. But let's just try to find something that I know that everybody can do. Just working it out. Now I'm going to put 5 in the 6. How many times will 5 go in the 6? Once with 1 left over, and I write that in front of the 7. How many times will 5 go into 17? 3 times with 2 left over. How many times will 5 go into 25? 5 times. How many times will 5 go into 75? Well, 5 goes into 7 once with 2 left over. 5 goes into 25 5 times. You can see I can do 5 again. Watch how I do it. 5 will go into 13. Okay, 5 goes into 13 how many times? Twice with 3 left over. How many times will 5 go into 35? 7 times. How many times will 5 go into 15? 3 times. And how many times will 3 go into 27? 9. Okay, so I did have to break that down a few times and reduce it, but we were able to get to the good number. Now at 32, I want to move him over 1, and I want to move him over 1, but what about this? Remember, that's a 1x. I have to move every term, so he's got to move over 1 also. So how do I move a 1? Well, that's like a 1 point. I got to add a 0, So that's going to become 42 plus 10x equals 98. Now I'm going to subtract 42 from both sides. And I get 10x equals, that looks like it's going to be a 56, divided by 10 by both sides. And all depends on how your teacher wants it. You can just write a 5.6. That works. You can go 28 over 5. You could go 5 3/5. It all depends on what your teacher likes. So any of these would be good, proper answers. Okay? Well, let's keep going. Let's go on the other side. All right, more decimals. I can see that he can be moved over once. He can be moved over once. So I just go 5x equals 36. Divide each side by 5, and I'm going to get x equals, well, that's an answer right there. You could go, I don't know, 7 1/5. It all depends on what your teacher wants to see, okay? But there's an answer right there. Okay, number 4. Okay, if I move him over 1, that's fine. Move him over 1, but I also got to move this over 1. So instead of a 1, which it is now, it's got to become a 10 because I have to move the decimal over 1. Okay, and now I get this. Now I just have a two-step equation. I'm going to add, forgot my x. That was really bad of me. Sorry. I'm going to plus 18 to both sides, and I'm going to get 10x equals 60. And then when I divide each side by 10, I'm going to get x equals 6. Okay? Let's go to number 6. If I move him over 1, him over 1, him over 1. Hey, I'm allowed to do that. That works out really nice and pretty. Okay, now I just do this problem. You can solve this. We've been doing these before. Let's add 15 to both sides. Boom, boom, boom. Die. 2x equals 50. Divide each side by 2. And we get x equals 25. Okay, we haven't done any fractions in a bit. Now this one, they all share a 5. So this one should be pretty easy. We're going to multiply the entire equation by 5. Now if you notice, that's going to just cancel out every one of them. And it just becomes x minus 6 equals 19. Well, now we feel more comfortable with that, don't we? We're going to get x equals 25. That's simple. All right, not as simple is number 10. So now, least common multiple. Here's the best way to do it. Take the biggest number of all the denominators, and in this case, it's going to be 8. You're going to multiply. Now ask yourself, will the smaller numbers go into 8? Will a 2 go into 8? And the answer is yeah, it is. Yeah, they will. And if the smaller numbers will go into the bigger number, your least common multiple is the bigger number. Because now watch what's going to happen. These 8s are going to cancel out. Remember, that's like an 8 over 1. And for the very first term, you're going to get x. All right, well, let's do the second term. 2 goes into 2 once, 2 goes into 8 4 times. What is 4 times 1? 4. Third term, 2 goes into 2 once, 2 goes into 8 4 times. We already have that. 4 times 5 is 20. So by multiplying everybody by 8, I now get an equation that I feel way more comfortable with, right? And now I'm just going to solve it like what we've done before. X equals 16. So these are nice little shortcuts. Let's look at number 2. All right, I see the 6. Will 2 go in the 6? It will. So 6 is going to be my least common multiple, and I'm going to times everything by 6. These cancel out, and I'm left with x. 2 goes into 2 once, 2 goes into 6 3 times. 3 times 7 is 21. That's the part that people forget sometimes, is to then multiply it after they do that. 2 goes into 2 once, 2 goes into 6 3 times. And that's going to become a 45. Now, this looks a lot better to solve, doesn't it? X equals 34. Cool. And let's do our last one. This one is pretty easy. We just move the decimal over once on all 3 of them, and then we can get rid of all of our decimals. Again, the only thing is you get some big, nasty numbers, but you know what? Those numbers are going to be just as big and nasty, just with a decimal in there somewhere. 4x equals, and that turns out to be 40, and I think you guys can solve it from here, right? And then we don't have any weird decimal problems. So this is one way. Here's the A. If that helped you, then when you get little challenge problems and fractions and decimals when you're doing, your homework in your class, hopefully these tricks can help you. Oops, sorry about that. And I hope they do. And if you need some more help, come see me in version B. All right, guys, good job. We'll see you there.